Question 11, Part D. Consider the function f of x equals x over 4 minus x squared. Part 1. Show that f dash of x is greater than 0 for all x in the domain of f of x. By the quotient rule, f dash of x is equal to u dash v minus uv dash over v squared, where u is equal to x, u dash is equal to 1, v is equal to 4 minus x squared, and v dash is equal to negative 2x. Hence, f dash of x is equal to 4 minus x squared, which corresponds to our u dash v, plus 2x squared, which corresponds to uv dash, over 4 minus x squared in brackets squared, which corresponds to our v squared. Collecting the like terms in the numerator, we get f dash of x is equal to x squared plus 4 over 4 minus x squared in brackets squared. Now, if we consider the numerator for all values of x, we know that x squared plus 4 is greater than 0. And if we consider the denominator, 4 minus x squared in brackets squared, now regardless of whether what's inside the brackets is negative or positive, when you square a number, it turns it into a positive, or if it's 0, squaring 0 gives us 0. But x cannot equal plus or minus 2 because that's not in the domain of f of x. So 4 minus x squared in brackets squared is greater than 0 for all real x, provided that x is not equal to plus or minus 2. Now, if the numerator is positive, the denominator is positive for all values of x in the domain of f of x. Positive divided by a positive gives us a positive. Hence, f dash of x is greater than 0 for all x in the domain of f of x. Part 2. Sketch the graph y equals f of x, showing all asymptotes. I'm going to start by considering the domain of the denominator of f of x, which is 4 minus x squared. Now, the denominator of the function cannot equal 0, since we'll get a division by 0 error. So 4 minus x squared cannot equal 0, which means that x cannot equal plus or minus 2. Hence, vertical asymptotes exist at x equals plus or minus 2. Now let's see what happens when x approaches plus or minus infinity. In other words, as x gets really large or really small, what happens to the value of f of x? So if we recall that f of x is equal to x over 4 minus x squared, so we have an x over an x squared term here. When x is really large, the 4 in the denominator has little effect, and x over x squared simplifies to 1 over x, and as x approaches infinity, or negative infinity for that matter, 1 over x approaches 0. Hence, as x approaches plus or minus infinity, f of x approaches 0, which means a horizontal asymptote exists at y equals 0. The function itself can never equal 0, but it will get very, very close to equaling 0. So the function will approach the x-axis for large or small values of x. Another point to consider is that f of x is an odd function passing through the origin, 0, 0. And we know that because f of x consists of an odd function in the numerator and an even function in the denominator, and an odd function divided by an even function gives us an odd function. So there's point symmetry about the origin. And from part 1, we have f dash of x is greater than 0 in the domain of f of x, and that implies that the function is monotonic increasing. There's no stationary points. So here's the graph. So I've drawn a neat set of axes there, correctly labelled. Here's the origin, labelled there as well. Here are the two vertical asymptotes. So we have x equals negative 2 and x equals 2. And here is a sketch of the graph. So notice that it's monotonic increasing, and it is symmetrical about the origin, or point symmetry about the origin. And that's it.